There's many ways to go about this. I do PEMDAS, so I focus in my parentheses, but nothing simplifies. So then I say, what comes next? Exponents. Oh, this does have an exponent. I need a...
screen is frozen.
Oh, dang. Okay, so then I need to make sure, are we talking? Why are we talking? We then have a power to a power, so I rewrite it so I don't mess up. I have an x to the 1/2, and then I go, you know what? It's silly to write y to the 0. Would you agree? Then I still have z squared. I'm just writing what I already had so I don't mess up. Now I have an x to the negative 1/2 right here, true?
Yeah.
And then I need to know how to multiply fractions. Isn't that y to the? Negative 3/8. That's how we multiply fractions, straight across. And then I say, I still have a z squared. I already wrote z squared. That's why I cross them out so I don't make an error. Y to the 0 is not necessary to write. I then put my y. Now, I personally don't want to make an error, so I write y to the 1. Do you agree or disagree? And then when I see this right here, this z to the negative 2, okay, so I guess actually I'll just write it. Now, this is my thought process. You know, I don't really want to deal with negative exponents right here, right now. That doesn't mean in the end I won't, but right here, right now I don't, so I'm going to flip any negative exponent to the appropriate place. This is good to go. It stays in the same position. This, however, needs to go to the top. True? We then have a z squared right here that stays here. Oh, dang nabbit. This needs to go up here. Crossing them out. Oh, dang nabbit. Yes? Y to the 3/8. This is getting annoying. And then we have a y to the 1. Now from here I say, okay, I should not have multiple x's in my final answer, or multiple z's, or multiple y's. So now I do the correct math. When you multiply 1/2 plus 1/2. 2/2, which is 1. So x to the 1. When you multiply
Add.
Okay. When you divide
Subtract.
and we have to do the top minus the bottom, and it has to be on top right now. Now, I'm not saying it's going to end up on the top. It might. So now I get a common denominator. I go divided by 1 times by 8 times by 8. So that's 3/8 minus 8/8, which is negative 5/8. True or false? So then I have x, z to the 4th, and then right now my y is up here, but that's not an appropriate final answer. So I bring it down here. Ding, 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 ding.
I had it all right except for the negative 5/8.
So where was your 5/8? Where was your 5/8? Or was it not 5/8? So close.
See, this many.
Yeah, I know, I saw it.
Nope, this is the only simplified answer right here. Yes?
Oh, there's two.
Like last year, we made like 25.
Were you what? When you're saying, I don't know if I know what you're saying. Yeah. Should I go back to the original? Like, can you come here real quick? I wonder if I can erase this. Yeah, okay. So you're saying, can I do what from the beginning? Like, what would you do from the beginning?
So if I just wrote it vertically, like sideways.
Oh, you mean, you can write it however you want. Are you able to get the right answer? Then you can write it however you want.
Okay.
Like, but I don't know how vertically would help. Like, you mean like up and down instead?
Yeah, because kind of like an equation, because it's the same thing.
But
It follows the same
simplifying
rules.
is actually backwards from solving. So simplifying, you do PEMDAS, but solving, you do this backwards. So you have to be careful.
Okay.
Do you see what I'm saying?
Yeah.
This isn't an equals 7, like, so we're not solving anything. We're just simplifying.
Okay.
But maybe you're not using the right wordage. Maybe you're not
I'm
using the
probably
right
not
wordage.
using the right.
Okay, but you could, like, look, if you wanted, you could say, I'm going to fix all negative exponents right now. Yes? So you could say this is z squared. True?
Yeah.
And then you could say, I'm going to bring these up here and say x, y to the 3/4 to the 1/2. Do you see what I'm saying? You can do stuff like that.
Okay.
Okay. All right. Okay, moving on. Start writing this down because you're not focused. Here we go. Continuing with 1.2. We're almost done. We are almost done. Let's finish up so we can actually work on homework, people. Focus, focus, focus. Don't talk. Stop, stop. Okay, here we go. 1.2. Write down this right here. A fun fact for you. Fractional exponents are equivalent mathematically to radicals. So this, x to the 2/3, if you wanted, and you might not want to, but if you wanted, you could rewrite it as the cube root of x squared. This and this are mathematically equal. So also, you could see this, the cube root of x squared, and you could change it to a fractional exponent. Now listen to what I'm saying. This is very important. Not one is more simplified than the other. It is all in the context of the problem in which you see where fractional exponents make the math easier or radicals make the math easier. If you take something with fractional exponents and make it a radical and now the math is harder, that's dumb because they're equal. Do you see what I'm saying? You only do it if it's beneficial to you because they are equivalent. Not one's better than the other. So, let's try to remember this, okay? So here's the thing. A lot of kids get confused. They forget. It takes a little bit of memorization. So everybody look. Do you guys see how the 3 is on bottom? The bottom is what becomes the root. See? Cube root. On top is the power. See? X to the 2nd power. So I draw this picture of a flower to help you remember. I would do it as well. So with a flower, there's roots. See, look, this is my fraction line right here. Roots are on the bottom of a flower. True? So that will help us remember roots go on bottom. The power comes from the sun and the sun comes from the top. So power's on top. So let's practice. If I have x to the 5/3 and say rewrite this in radical form just for kicks and giggles, not to make it more simplified, that's not what we're doing. We're just doing it for fun. What would be the root? 3. Yes, everybody. Yes. Roots are on bottom. And then it would be x to the 5th power. Now, would this be equivalent mathematically? Watch. Yes. What if I chose to write it as the cube root of x to the 5th? Yes, it's the same thing, right? Sometimes they write parentheses, sometimes they don't. What if we did this? Fun fact for you. You also could write it like this. The cube root of x and then to the 5th power out here. It's just 3 different ways of writing the same thing. So the 5 could be under the root or on the outside of the root. It's still a 5th power, isn't it? Yeah. Okay, so it doesn't matter how you write it. All right, so I want you to write down these 2 examples so you can refer back to them in your notes. Let's write them down. These blue ones, the blue ones. Now, once again, this is a shift of gears. It feels very random, and it is. Honestly, I'm looking at this thinking, for right now, it feels random. Today, in today's lesson, it is just random. It says, write the expression in radical form. Right now, it's in exponential form. Exponential means, like, there's exponents, not radicals. So they just want you to switch for kicks and giggles. So what would we do? We would call this the what root? Square. The square root, yes, of? P to the 3rd power. Why did I leave it blank? Because we all know that it secretly means a 2. True, everyone? All right. All right. Now, everybody focus with me. Wouldn't you agree that right here, the parentheses are stating that both 2 and P are both raised to the 3rd power? And they're both under a square root. True? So parentheses matter here. Both 2 and P need to go under the square root. Yes? Look, 2 is on bottom. Do you guys see why I'm saying square root? Both P and 2 need a 3rd power. So we need to go like this. We know it's under the same root. Look, it's in parentheses. It goes under the same root. The root's a square root, so I don't write 2. But now we need to make sure we use parentheses. Both 2 and P have a 3rd power. Okay. Now look at the next one, yes?
Outside of the square root and then a P inside.
We're not going to then simplify it. This is not the point. The point is, for kicks and giggles, write it as its other form. Don't then simplify it.
So we always have to bring the parentheses in.
Island.
Yes.
Oh, I get this one already.
Okay, look at this one. This one tricks people. Write this in radical form. Yes.
I'm so sorry.
Yes. It's 2. 2 has, everybody look, 2 has a first exponent, true? Only fractional exponents are radicals. So this has nothing to do with the radical. It's a tricky question. So we would say 2 is on the outside and it's times 2 to the square root of p to the third power. Now, I didn't use parentheses because it was just a p. You know, but could I? Yes. It just kind of feels unnecessary.
Facts.
All right, look at this one. Let's try this one. What would we write? Are they all under the square root? So let's write 1 square root. Are they all to the first power? So we could go 3xy to the first. Now, is it unnecessary to write that? The first. Yes, I get it. But that's besides the point. The point is, do you know how to switch to this format? Not do you then know how to simplify it? No, don't simplify it.
That way we don't have to write anything. We just have to put the whole thing in.
Okay, let's go the other way. Write this one as a fractional exponent. Watch what I do. I just write the base as is. Then I put a fraction line. I put the root where the root goes, the power where the power goes. What's the root here?
4.
Where does it go? On the bottom, like a like a flower. True? Like the flower has a root. And then the power is 5. Done? Good to go. Roots are on bottom, powers are on top. Look at the next one though. Okay, let's do it. Are both 2 and x like this in parentheses?
Yes.
All right, then what's the root? 4. What's the power? Now double check. Is that right? Are they both under a 4th root? Are they both to the 5th power? Yes? So yes, we're good. Okay, let's look. This next one tricks people. Look at it. Just think. Think with me. Are they both under a 4th root? Yes, they are. Look at it with your eyeballs. Are they both under that 4th root? But do they both have a 5th power? So you have to be careful. What's the power on 2? 1. So we need to say, so 2 to the 1st is 2 to the 1st. X to the 5th is x to the 5th. But then aren't they both under the same root? So now we put parentheses and say they're under the 4th root. Do you guys see?
So if you go
Yes.
to the last one,
Hold on. Let me finish, then we'll go back up. So then what power could we put on top that won't change my original powers? 1. This is the correct answer.
so to solve it,
So let's not solve. Don't. I'm gonna make you use the correct lingo. To rewrite it, you mean? To rewrite it? You're saying to
so
solve.
if it's 2x to the, do you do 2x to the 5th power divided by 4?
Yeah, because they both were to the 5th. Do you guys see right here? Well, this one, they both weren't to the 5th. They had their own exponents. So we had to leave them separate. We can't put a parenthesis and put a 5 outside. Otherwise, you're saying 2 is to the 5th. So it is tricky. You got to think a little bit. It is tricky. You're not alone. Okay, let's practice this one. Are all of them to the 3rd power? Look. No, so we've got to leave them with their own powers. Aren't their own powers a 1 and a 1? So go 3 to the 1st, x to the 1st, y to the 3rd. But they are all under the same 5th root. So now I do need parentheses and put a 5th root. And then you're right, the power on top that we put will not change the powers we have is a 1. All right, it is tricky. It just takes some thinking. We're almost done with the lesson. All right, so what would this one look like? Are they all to the 3rd power? Then this is the easy one. 3xy is all to the 3rd power and all to the 5th root. Do you guys see? All right, look at the difference. Awesome. Now, here's what I need to be very clear on. Listen to what I am saying, my friends. I think some math teachers don't say this. Just because I taught you how to take a fractional exponent and make it a radical doesn't mean that's going to make your problem easier. Now, look at what I'm saying. If I were to take this and say simplify, once kids learn that they can change fractional exponents to radicals, they think you just always do that. Watch how hard that would make this problem. If you're like, oh, fractional exponents are radicals, then you're going to go like this. You're going to go the square root of x cubed, the square root of y to the 1st. And then you're going to say, and then that's under the cube root. You guys, that's making it worse. Why are you doing that? You don't need to do that. Instead, leaving it as a fraction is better because then can't we just multiply, yes? So just because you see a fractional exponent doesn't mean go switch it to a radical.
So we're just learning this for the future.
We're just learning it for the future, for kicks and giggles. Okay, awesome. Now everybody, now I need to answer some questions. For one, yes, I have usually some bell quizzes. I try to help boost your grade up. Are you listening so you all know what you're going to do? I try to boost your grade up by giving you a bell quiz that's not math related. It's just to get to know you. And so then you get full points for just participating. So sometimes we don't get to that in here. And if you do it at home, that's just going to help your grade. It's so that I can learn things about you just as a person. So those are always titled the date. We will do some of those in class. When I feel like the lesson might be long, I usually try to just get to the lesson first. Then you are going to submit a quiz. There is a quiz that helps you check your answers. It's the odd problems on your homework. So you would go submit, I got this answer, this answer, this answer, this answer. That way you know if you got it wrong. If you get it wrong, do you cry? Do you hoot and holler? No, you fix it and it's good. You're gonna get back the points. How do you fix it? On a piece of paper, you'll say quiz corrections and you'll hand it into the basket. Do you all understand?
Is this for the accuracy quiz?
Yeah, this is just for the accuracy quiz. And then how do we submit homework? We didn't really go over that last time. You will take a picture of the packet that you just wrote on doing the homework and submit me a picture so I can see that you're actually doing homework. Does that make sense?
Do you check the answers?
You're checking your own answers. There's answers on the back.
So what if we got it back? Wow, this is so much better than last 2 years.
What?
If we get multiple points on the accuracy thing, we have to redo it.
No, you just should fix it so that you know what you're doing for the test. I am gonna not give you points back until you fix it.
So like in a practice.
No, fix it on a separate sheet of paper and then hand that in person.
How are you planning on using that to